The diagram shows a light inextensible string passing over smooth pulley B. A connects a particle A of mass 2 m, so 2 mg right there, capital mg, and then second pulley C of mass m. This time the pulley is not weightless. This time this pulley here has its own mg going right through the middle. Are we happy with that? Then what's D? D is mass n, which is mg. E is mass 2 mg. Like last time, T1, T2. Okay. Let's assume, I think it's very convincing this time that this is going up at A, C is going down at A. What about the mini system here? E is going down and D is going up. Okay, let's begin. Let's go for particle A. So what can you tell me about particle A, guys? Up or down? Up. Okay. What's dragging it up? T1 minus 2 mg equals 2 ma. Points on the board, 5 marks. Next one, particle C. Oh, sorry, pulley C. Okay, C, what's happening to C? It's getting pulled up by, anybody? Pulled up by T1. Getting pulled down by T2, another T2, and it's also getting pulled down by its own weight, which is mg. So I want to make sure, yeah, mg. Okay, so let's do this, okay? We're assuming it's going down. Let's start off with the downward forces. What's the downward forces? 2T2, yeah. Plus, minus, equals, ma. Okay, so far, equation 1, equation 2. Okay. Particle D. Is D going up or down, or is it debatable? Overall, is it going up or down, or is it debatable? Debatable. Pick one. Up or down? Up. Let's go up again, okay? So, what is making D go upwards? What force is making D go upwards? T2. What's making it go down? mg. Its own mass. Its acceleration. Now, upwards, you're going to start off with its upward acceleration minus its downward. F minus A. That's excellent, lads. Right? That's really good. F minus A. Okay, so you have F minus A there. Alright? Multiply it out. T2 minus mg equals mf minus ma. And now particle D is done. Once again, quick circle of your work and move on. Particle E, guys. Particle E. F equals ma. Up or down? Down. What's driving it down? 2 mg minus T2 equals 2m A plus F. Okay. finally 2mg minus T2 equals 2ma plus 2mf. Now, that's the really easy part. The really easy part is making them. The really hard part is using them. So it's the exact opposite of the exercise we did before, where it's really difficult to make them, but once you make them, it's easy. Okay, and finally, yep. So it's always good to circle your work in a different colour just so you can find it in a test, because your solutions will be massive at times, so you need to be able to find what you're looking for. Okay, 4 equations. I tend to go through the same system over and over again. I tend to just go straight after the t's and try to eliminate them and get a simultaneous equation with a and f in it. Okay, I'll see if I can do the same thing this time. So what does it want me to do? It wants me to find the common acceleration. It wants me to find out what a is, and then it wants me to find out what f is. But at the very end, it wants me to calculate the magnitude and direction of the actual accelerations. The actual accelerations is f minus a and a plus f. That's the actual acceleration. So an example would be if I'm on a pulley and I'm dropping down 5 meters per second squared on that pulley, but that pulley in turn is dropping down 3 meters per second downwards. Overall, I'm going 8 meters per second downwards. Okay? So that's what you got to take into consideration. Now, relative to my pulley, I'm going 5 downwards, but relative to what I'm actually doing to an observer not on the pulley is I'm going down 8. Does that language make sense? Relative to as opposed to actual acceleration? Okay, so those numbers are just random numbers I pulled out thin air just to explain the concept, and now we're going back down. Okay, I am going to start off with T1 here. I'll call it A, B, C, and D. Always write down the equation you use when you rewrite it. So T equals 2mg plus 2ma. That's equation A. Equation C is, T1. T2 ends up to be mf minus ma plus mg. Okay, should be able to get another one. A as well. Oh, sorry, I already used. That's D. Excuse me, that's D. Now I'm going to use A. Equation A is going to be T2. I'm going to bring it on its own to the right, then bring everything else to the left. Just keep it in my head here. It's going to be 2mg minus 2ma minus 2mf. Is that okay? And which one have I not used yet? B. Now, B is B. Okay. Here's what I'm going to do. I'm going to use A and C against each other. So I'm going to create equation E. Now I do it like this, guys. I keep a track of where it comes from. E is coming from a combination of A and C. Do you ever do a big, massive long equation only to find out 0 equals 0 or 5 equals 5? It means you double used your information and you learned nothing from it. Keep a track of your information, okay? Where it's coming from. E is coming from A and C. So we're going to get MF minus MA plus MG equals 2mg minus 2ma minus 2mf. Okay, what I'm going to do is going to move the a's and f's over one side, and anything else can go to the other side. Now I'm noticing that there we go. So that's minus 2f, which is going to turn into plus 2f. That'll get me 3f. And then that's minus 2a, which is going to turn into plus 2a when you bring it over to the other side. So that's going to be just plus A. That's G, which is going to turn into minus 1G. Minus 1G, 2G take away G, is just G. There is my first equation, stemming from A and C. Now, what I'm going to use next is I'm going to use equation B. So equation B here, I'm going to drag it all the way down to the bottom because this is going to be a very long equation. Bringing down equation B here. I can choose either T2 I want. I don't know which one I'm going to choose just yet. I'll choose one of them. I'll choose the second one. Numbers are smaller. So the first one, I'm going to choose equation C. So equation F, which is what I'm going to do now, it's going to be derived from equation C and equation D and B. It's a triple one. Three equations into one. Okay? So multiply this by 2. So I'm going to get 2mf minus 2ma plus 2mg. And I've only done this part. Now I have to add on the mg. Now I have to take away T1. Minus T1 is minus 2mg minus 2ma. Minus 2mg minus 2ma. Okay. So that part is done. The mg is there. The minus T1 is there. Now I have to do the ma. Now, I've done my job right. See the way that's A? I'm just going to quickly change that to minus 3A just to make the whole thing a bit more trackable, all on one side now. So 2F, anybody see any other F's? No other F's. 2F minus 2A minus 3A is minus 5A. 2G plus another G minus a 2G. Alright, 2 of them just cancelled each other out anyway. And that's just going to be plus G, yeah? Move that G over the other side. Minus G. Equation F from equation E. Solve simultaneously. 3F plus A equals G. And 2F. I'm just going to multiply. Oh yeah, I can't do that just yet. 2F minus 5A equals minus G. Multiply the top one by 5. 15F plus 5A equals 5G. 2F minus 5A equals minus G. 17F equals 4G. F equals 4 over 17G. That's correct. Finally, figure out what A is then. A equals G minus 3F from just bringing that over to your side. A equals 1G minus 3 times 4 over 17G. That's 17 over 17 minus 12 over 17. A is going to be 5 over 17, is it? Now, one last second. That's A and F, that's grand. But what they want me to find out is the actual acceleration of particles D and E. So D and E. What's D again? D is F minus A. D is F minus A, and E is A plus F. So here we go. So it's going to be 4 out of 17G minus 5 out of 17G. What does that mean about particle D? Sorry? Yeah, but it's still okay. You don't have to fix it.
Yeah.
So we argued, what way did we argue D was going at the very top? We argued that it was going up, but because we got a negative answer, it means it's actually going down at 1/17 G, and finally A plus F, there's only one way this is going. 9/17 G.